Hello and welcome to T2 Day 14 of Honors Precalculus. Let's review some right triangle trig. So here are two triangles, and the things that it tells us are certainly true. We have a right angle there, and then we have two angles, one here and one here, that are congruent. So if two angles are congruent, two pairs of angles, those two and these two, what that means is this angle here has to be the same as that angle there. So what does that mean? We end up with triangle ABC is similar to triangle DEF. And this means that the corresponding angles are congruent, but then the ratios of the sides have the same ratio. What that means is B over E, so B to E has to be the same as C to F, which has to be the same as, for example, A to D. So what it means is there's a constant that you can multiply the lengths of this triangle by to get the lengths of that triangle, and they're going to be the same. So another way to say it is you could say things like A is to, another way you can say it is A is to B. So A to B is the same thing as D to E, for example, D to E. And another thing you can say, for example, is C to A. C over A is the same thing as F to D. So there's lots of ways in which you can write ratios between sides because you know these are similar triangles. They're similar triangles, and we did that with angle, angle, angle. So the angles that were the same, this angle and this angle congruent, right angle, so they're congruent. So two of them are the same, so therefore this one has to be the same. So by angle, 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 they are similar. So when it says give the ratios names here, give the ratios names, what we need to know are, well, really just one thing. We have SOHCAHTOA, which is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if this is theta right here, what does that tell us? It tells us this. This for the three first trig functions, and then there are three others. Remember that there's cosecant of theta, there is secant, not a C, secant of theta, and there's a cotangent of theta. And what you need to remember is that these are just the flipped reciprocals. So if this is opposite over, cosecant is going to be hypotenuse over opposite, and I just caught one small mistake here. This is opposite over hypotenuse right here, HYP. There you go, found it. So then secant is going to be the reciprocal of this, so it's going to be hypotenuse over adjacent, and cotangent is going to be adjacent over opposite. These are the side lengths. So remember, they're reciprocals. So opposite over adjacent becomes hypotenuse. Opposite over hypotenuse becomes hypotenuse over opposite. Adjacent over hypotenuse becomes hypotenuse over adjacent, and then tangent opposite over adjacent turns into cotangent, which is adjacent over opposite. They're reciprocals, reciprocal and reciprocal. Please remember that, which is the same thing as 1 over it. One other note is that the reciprocal direction you can go backwards too. So if you flip over cosecant, you get sine. So here it says, given the following triangle, evaluate the 6 trig values of theta. So the first thing we're going to do is we need to know the length of this side right here. And we're going to do that by using the Pythagorean Theorem, which is 24 squared, we'll call this h, plus 10 squared is equal to h squared. So you can do this out, and if you solve this, you get h is equal to 26. It's a really nice number. It's not an irrational number. So what you'll notice is that you can simplify these. 10 you could reduce to 5. If you reduce that by a half, this would be 12 right here. And you need to remember that there's a triangle 5, 12, 13. So it would be 13 times 2 is how we get 26. So you could recognize this as 2 times a 5, 12, 13 triangle, where this is the 13 side, but it's double it, so that would be 26. Just another quick way to see it. 5, 12, 13 is the same thing as, so if it was 5, 12, 13, we double it to get these final values, so it's going to be 26. So now that we know this h is 26, all we do is fill in the blanks. So just the first one, sine of theta, is going to be 5 over 13, 10 over, it's 5 over 13, but before you reduce it to 5 over 13, it's 10 over 26, so 10 over 26, reduces to 5 over 13. Cosine of theta is 24 over 26, so that's 12 over 13, and it's just doing all of these ratios. And then tangent of theta is going to be 10 over 24, which reduces to 5 over 12. And if you remember properly, the reciprocal of sine is cosecant of theta, the reciprocal of cosine is secant of theta, and the reciprocal of tangent is cotangent of theta, and all you do is you flip these over. So this becomes 13 over 5, this becomes 13 over 12, and this becomes 12 over 5. So if you get the first three, you can easily get the next three. So if we know that sine of theta is root 2 over 2, and the terminal ray, the ending ray, lies in the first quadrant, evaluate the other 5 trig functions. So what that means is sine of it is root 2 over 2, and sine is the y-coordinate. So we know that the terminal ray lies in the first quadrant, so it's going to be in the first quadrant, which is this quadrant, the first one. So what that means is sine is root 2 over 2. So we have this triangle right here, where we know that sine of this angle is root 2 over 2. Remember, sine of theta is equal to sine, so opposite over hypotenuse, and we know in this case it's equal to root 2 over 2. It doesn't say this is the unit circle, so this is going to be our opposite side, and this is going to be our hypotenuse. So we're going to have 2 here as our hypotenuse, and root 2 here. So what does that mean for our base right there? So if we do that, we know that b squared plus root 2 squared is equal to 2 squared. So b squared is equal to b squared plus 2, because root 2 times root 2 is 2 equals 4. So b squared is equal to 2, so b is equal to the square root of 2. So this is root 2. So we have this triangle right here, and that allows us to then write the cosine of theta is going to be the adjacent side, so root 2 over 2. And then the tangent of theta is just going to be root 2 over root 2, which is 1. And then we just flip them all over. So cosecant, remember, is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. You flip all these over, and you end up with 2 over root 2. You end up with, again, 2 over root 2, and 1 over 1 is just 1. Now, you might see these written a little differently because you can multiply this by a form of 1, which is root 2 over root 2. That's just a form of 1 right there. That equals 1. But when you simplify this, you get 2 root 2 over root 2 times root 2 is 2. It cancels, and you're left with just root 2. So a simplified version is just saying it's equal to root 2. But once you get the first 3, again, you can get the second 3. So similar question, we have cosine, and it's in the terminal ray is in the second quadrant, so that's over here. So that means we have a triangle in the second quadrant here, and cosine of the theta value is going to be negative 4 over 5. So that's, remember, adjacent over hypotenuse. So this is negative 4 and this is 5. And if that's negative 4 and that's 5, this has to be a height of 3. It's a 3, 4, 5 triangle. So that tells us the sine of this angle is just going to be 3 over 5. The 3 over the 5, sine, so opposite over hypotenuse. The cosine, it already told us, is negative 4 over 5, and that means that the tangent of this angle is just going to be 3 over negative 4. So then, again, the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is, sorry, I got to write that properly, cotangent of theta. So you flip all these over. You literally just flip them over, and you get 5 over negative 4. It's the same, negative 4 fifths and negative 4 thirds. You can put the negative in front. So you could write this as negative 5 over 4 if you really wanted to, and negative 4 over 3. It's totally fine. Again, you get the first 3, and it gives you the second 3. A key, though, is drawing this picture and noticing it's a 3, 4, 5 triangle. So let's solve these. What does it mean? It means find all the sides in the angles right here. So we have like a base and a hypotenuse here. So we know that sine of 40 degrees is equal to sine, so opposite 8 over the hypotenuse. That's one way to do it. You could use that function because then what you can say is cross multiply and you get h times sine of 40 degrees is equal to h times sine of 40 degrees is equal to 8 times 1, which is 8. So h has to be 8 over sine of 40. Now this is something you can just plug into your calculator, And if you do this, you end up with h is equal to 9 point, sorry, not 9. H is equal to, you end up with 12.446. And just remember that you're in degrees right here. You have to be in degrees for this to work. And then once you have the h being 12.446, you can use another trig function, but you also can use the Pythagorean theorem here. You also know that tangent of theta is equal to 8 over b right there, and theta is 40. So tangent of 40 degrees is equal to 8 over b, 8 over b, not 8b. So that means that b is equal to 8 over tangent of 40 degrees. You use a calculator for that, and then you end up with 9.534. So we have the b value right there, and we have the h value right here. How do you get the other angle value? Well, we know that this is 40 and this is 90, and they have to add together to get 180, so that has to be 50 degrees. So that's solved. Let's do another one. 9 and 15. The base here, a, one way to do it is a squared plus 9 squared is equal to 15 squared. So a squared is equal to 225 minus 81. So a is equal to the square root of 225 minus 81. And if you do that out, you end up with a is equal to the square root of 144. Oh, so a is 12. When you get a nice answer like that, so we have this triangle here, which is 12, 9, and 15. That's similar to, divide them all by 3. What do you get there? You get 4, 3, 5. It's similar to a 3, 4, 5 triangle. Just something to keep in mind. You might have just seen that it's 12. So how do we get the other angles there? Well, we know if this is theta right here, sine of theta, so opposite over hypotenuse. Opposite over hypotenuse is going to be, opposite 9 over 15. So theta is equal to sine inverse of 9 over 15. You have to use a calculator for that, and end up with 53.130. So if that's 53.130 degrees, this angle right here is just going to be 180 minus 90 minus 53.130. So that means, so theta is 36. This is not 50, this is 36. Excuse me. This is not there. I copied the wrong number over. This is 36.870 when you do that on your calculator. So 36.870. So 36.870, and you subtract it to get that one, this angle right here. And when you do that subtraction, you end up with 53.130 degrees. So we have our 53 right there. We know that that angle right here is 36, and we know that the other side is 12. So it is solved. So when you're reading this question and you're doing this question, the best thing to do is draw a picture of what's going on. And what you need to first know is what bearing means. That means degrees from to in a clockwise direction from due north. So what this means is initially the plane is going 110 miles an hour, bearing of 40 degrees. So due north is straight up. So initially the plane is going 40 degrees from that, going 110 miles per hour. So it's 40 degrees off of true north. And then it turns and continues another 1.5 hours, so it's 1.3 hours here. And then I'll do a second leg, and it bears 130 degrees. So if due north again is still straight up, 130 degrees from there is going to be more like this right here, because this has to be 130 degrees. And it's going for 1.5 hours at the same speed, 110 miles per hour. It goes like that. And then it asks, at the end of this time, how far is the plane from the starting point? So it's asking for this distance right here, and what is its bearing? So what we're going to do here is we need to solve this triangle. All this is asking is solve this triangle. So the first thing we can do is the lengths of the sides here. We can do the lengths of the sides. So what that means is it can get a little complicated, but what's really nice here is that we know that this angle right here, we actually know that this angle right here is 90 degrees. And we know that because you can think of it also going straight down to south right here. And if this is 130, this has to be 50 right here, 50 degrees. And because this is 40 right here, this has to be, this has to be 50 degrees right here. but that's a right angle, so 50 and 90 leaves you with just 40 degrees right here. So this angle right here is 90. That's the important thing. Why is that helpful? Well, that means that you can solve for this distance, this green distance, pretty nicely, because first of all, the green distance, the first leg, it's 1.3 hours at 110 miles an hour, which is 143 miles. So that's how long the first one is. And then the red leg is 1.5 hours at 110. So that's going to be 165 miles. And because this is a right angle, we can use the Babylonian formula identity, which is going to be 143 squared. And we'll call this, let's just say C right there. 143 squared plus 165 squared is equal to C squared. When you do this out, you end up with the square root of that sum. You need a calculator. It turns into 218.344 miles. So that answers the first half of the question, which is how far is the plane from its starting point? Well, it's 218 miles, 218.344 miles. Now, what about the angle itself? How do we do that? One quick note here, I want to clean this up a little bit, is that if this is 40 right here, the angle that's made right here is 40. And if this whole distance right here is 130, 130 minus 40 is 90. So you know that this side is 90 and therefore this side is 90. So it's 90 and 90 because it's a straight line. This is not necessarily 50. I wanted to clean that up because that's actually what we need to find, that angle to find the bearing we're going to get. The bearing of this green right here, the bearing of this green is going to be 40, which is the bearing of the first leg, plus this theta right there. So we need that theta. The way we get that theta is that's just going to be tangent of theta is going to be 165 over 143. So to do this, you do the tan inverse of 165 over 143. And when you do that, you end up with 49.086 degrees right there. So that means this right there, that angle right there is 49.086 degrees. 86 degrees, not 0 degrees. So again, this angle right here has to be 90, so this one has to be 90. That's how we ended up being able to do the Babylonian theorem right there. So what that means is the bearing pointing at where the plane is right here, that's where the plane is at the end here. The bearing we want is this angle, so that's 40 plus theta. So the bearing is 40 plus 49.086, which is going to be 89.086. Having trouble with the decimals today. 86 degrees. We'll definitely go over this in class. There's a lot to break apart here. But to give you a cleaner picture here, what's going on, if this is north, the plane ends up going first 40 degrees off of true north for a total of 143 miles. And then it turns like this, and it ends up going 165 miles right there. So then it asks, what's this distance right here? We found out that that distance was 218.344, and it wanted this angle right here. But we found out this angle right here was 49.086. So the whole angle had to be 89.086 from true north. So that was the distance from, and that's the bearing right there if you clean it all up. And we knew that because if this is 40, then you continue here. This has to be 40 degrees right here, but this right here is 130 degrees. 130 minus 40 is 90, so that has to be 90. Therefore, this has to be 90 because it has to add up to 180. That's where that 90-degree angle comes from. And again, we'll do it again in class if you need to.